Hey guys, how's it going? So in the last one, got a little bit stuck on the segment splitting. So we got the spline detection working. So we'll just quickly show that. So we've successfully got the splines detecting overlaps on itself. Then I very quickly hit a wall when it came to dissecting the segment into those separate sections. And really what the issue was is we're getting an array of intersections, and what stumped me was when we try to cut the spline up, if we make the cut at the start, then the rest of the intersections are not going to be valid because the rest of the spline won't exist. So similar to iterating over an array where we might delete elements, we're actually going to go backwards. And this is feasible because when we do the collision detection, we work our way along the spline, and so they're in order, in which case it means we can reliably work on the principle that they're going to still be in order when we start to dissect the segment. And we're going to work away from the end of the spline and go backwards. So as we cut ends off the spline, the remainder is still valid, and we should be left with the different segments made up of the different splines. I'll kind of show the so last week, as you can see here, I made a start and then very quickly realized what I was going to do wasn't going to work. So I've kind of outlined the steps here. So there's going to be split segment single, so that'll be for when there's a single intersect info. Split segment multi, which we'll then call the split segment single. So we'll check that the base segment is valid, yeah. Get the number of intersect infos, because we're going to need that to know how many iterations to do. Do a for loop starting with the last index, which will be the number of intersect infos minus 1, going backwards, and then making a call to split segment single, passing in the base segment and the current intersect info of that iteration. So that split segment multi will be passed in an array of intersect infos, which, as I mentioned, should be in order. So we're going to go from the end of the spline going backwards. And that split segment single is going to get the index of the control point where the intersect was found, and that's stored in the intersect info struct. So we've already got that data. Get the location of the intersect, create the new spline component, and its first control point will be the intersect location. So that'll be the start of the new spline. Then we copy all of the remainder control points from the original spline onto the new spline. So it's got the intersect location plus the remainder of the original spline, and that will give us our new section. We create a new segment actor, passing in that new spline, and I will need to create a initialize segment method for that. Already have one, but it takes in the actual raw target info. So we're going to create a overrider method which takes in an already created spline, in this case the one we're creating now. Then on the original spline, once we've created that second spline, we can then delete all the control points after the one that's in the intersect, and then add one to the end where the intersect location is. So the end of the original spline is now the same location as the start of the new spline, and that can return that segment. So that will return a pointer to that newly created segment. This will have an array of newly created segments, and each time it calls the split segment single, it will add the created segment to an array, and then this will return that array of new segments. Then after that, the network actor that's actually calling all of this will be able to do whatever it needs to do with those new segments. So that's kind of the outline of it. I'll probably create this method first. It should be fairly straightforward. Then it would probably make sense to then make the split segment single method, and then finally make the split segment multi section. And if all that goes well, we'll put that into the code where it needs to be. But there's quite a bit going on here. So starting with this initialized segment, if we take a look at how it currently works, this base method, so it takes in the data asset and the raw target info. And this is the target information from the gameplay ability target info, target actor. And all that really does is it creates a spline component using that target data and just stores that to segment spline. So actually this overridden method should be fairly straightforward. All it's going to do is take in a spline and just store it to segment spline. So be nice and easy. So a nice easy start in theory. And we can use the same method name because we're giving it a different parameter. When you call the method, depending on what data type you use to call it, it will call the correct method. So that's the data asset that makes up the network item. So if it's like a road asset, for example, so we have a data asset ready for that. And we're going to be passing in a spline component. And that's going to be probably a pointer. Yeah. Okay, that should be fine. So this will be pretty much the same. Might as well just copy that. And actually, yeah, so all we've got to do is just store that. Cool. And we may as well check it's valid. not really necessary for safety because we're not doing anything with the spline at the moment. But it will be useful just to have that error message if we try to pass in a like a null pointer. Cool. Okay, well that's the easy bit done. Now we're going to move on to this. So we're going to want it to return a proper pointer to a segment component. It's going to take in probably a weak pointer to the base segment and the intersect info. Yeah, okay, that's fine. And a bit like this one, it's going to be a static one. So it's going to return a transport network segment. Split segment single. And we want it to take base segment and intersect info. Okay. Base segment. Then the intersect info. Yeah, so just a single one. Segment, intersect info. Gonna be const. Yeah, I think that's right. So that will give us the control point, the location. We'll be able to create a new spline component, and that will be given to the new segment. Yeah, that should be fine. That signature seems okay. So okay, we don't really need to explicitly do these because they're just in the struct. Okay, so we need to create a new spline component. Set the initial potentially clear any ghost control points because it may initialize with some already there, so we need to make sure just to clear those. Then add first control point using the intersect location found in the intersect info. Okay. Then we need to do what? So that will be, we'll need to loop over all of those. On the original, so we'll need to get the spline component of the base segment. Okay. Then iterate over the base segment spline, starting from the index +1. Then for each control point on the base spline, copy and add to the new spline. Right. Segment actor, yada yada yada. Yeah, so then we can create the new segment actor. Initialize it. Okay. Then on the original spline, delete all control points. Okay, so can we just do that in one go? Potentially, but just to keep it simple. So that again. And delete control point on the baseline. Okay. Then finally add point to the baseline. That has the location of the intersect. Cool. And then finally return that's roughly it. So it could end up being quite a long method. There'll probably be some refactoring to do later. That's fine. So let's see. Actually, let me just see, how do we do it here? I don't know. Oh, I see. Okay, so we'll need to pass that. And we could probably just pass that as a actually no, let's use the segment as the owner. So if we create the segment actor first, and at the moment when we create the segments, which is the items, So yeah, we've spawned a physical actor. Okay. So we'll just spawn the new segment beforehand and assign that as the owner to the temp spline, which makes sense anyway. So so similar issue here because it's a static method. We're going to have to pass. What does that take? UWorld. Okay. UWorld. Okay. That should give us access to spawn actor. Let's just check that it is valid. So now we should be able to do that. Spawn actor. What? Okay. Let's just try change that to that. Okay, cool. I think it likes that. And is that entirely necessary having this? No, it shouldn't be. Let's get rid of that. Okay, check it's valid. And then finally we can go back to creating a new spline and set the new segment as its owner, which makes sense. Okay. see if there's a built-in method for clear spline points. Sounds good. Okay, now we add the first point of the spline. Is that what we want? I think so. Spline point. Okay. Sure. Position equals, then we pull that from the intersect info. Cool. Cool. Alrighty, so now we need to get the spline component of the base segment. That might be private. Let's see. Yeah, so let's create a method. Can you give us okay, gonna make us do it manually under split segment single. Called it, yeah, but it's that. sure that compiles. Nope. Oh, my bad. Did not know that. Okay, cool. Try that again. Okay, cool. So now we're going to iterate over the control points starting from the intersect index plus 1. Okay. Less than okay, hold on. Okay. So that will give us the last index of the spline points. So I less than spline last index I plus plus. Why is that given us? Oh, right, yeah. What was that? Hold on. Cool. Okay, so on the original spline, starting from the next control point after the intersect, we're going to copy those over to the new spline, which should be reasonably easy. There should be a way of getting the control point at location. Get the spline point at, there we go. F spline point. Cool. So let's do that. Which is going to be I, E spline coordinate space, world. Then we add that to the new spline. Oh. So that just takes in a position. Alright, okay, that's fine. Just so don't forget, let's update. Okay. So now that we've created the actual spline component, we should then be able to initialize the new segment actor. And we should be able to call this. And we need to get the data asset. What about let's do this. And we're getting that from the base segment. Okay, and then the initial spline, which is the new spline. Cool. Okay, now we do the for loop again, but this time we delete them from the base segment spline. And we probably want to do this in reverse as well, because it's going to be otherwise it's going to mess up the indices. Sorry. Just rewrite that. So I should be initialized to spline last index. I greater than or equal to 0. I minus minus. Then we should be doing that. Get rid of that. So we're starting from the end of the spline and deleting the spline points, going backwards. And that means we're not going to be messing up the indices as we iterate over them. Okay. And we don't actually want to do that yet. I'm going to do this later. So we now add the insert location to the yeah, we can actually just copy that, I think. Alrighty, so I think that might be that method done. Not ready to actually test it yet. Let's just have a little look. So we get the game world, yeah. Create a new segment actor. Yeah. Create the new spline, which will be owned by that new segment actor. We clear any spline points just in case. We then create a spline point based on the intersect location, and we add that as the first point of the new spline. We get a pointer to the spline component of the original segment. We start by iterating over the spline points from the original spline and copy those over to the new spline. We then give that created spline to the new segment, so we initialize it with that. Then on the original spline, we remove those points that we've copied over to the new one. And then once we've done that, we then add that intersect location to the end of the original spline. So the end of the original should now be the same as the start of the new one. And then finally we return the new segment. So in theory that should be all good. So now you should be able to make this method, which should return an array of new segments. And this should be reasonably straightforward. This would just be a case of iterating over the array and just calling this method that we've already created. And we will need, similar to that one, we'll need the base segment, take an array. Okay, that should be fine. So this will be static, and we want to turn an array of segments. Split segment multi. So it's going to take in the base segment that we're splitting, and it's going to take in a T array of segment intersect info. That should be out. Check that the base segment is valid. We should check that the intersect info is more than 1, or more than 0. We should iterate backwards over the array. And then call split segment single in each iteration. Okay. Create an empty array of segments. Return segment to the array. Oops, new segments. Return the array of new segments. Cool. Do we need any other? That should be fine. Let's do. check that more than 0. Right. Okay, then so that's our empty array. Let's just, this shouldn't be necessary, but still. You never know. Then iterate backwards. So it's going to be insect infos.num -1 will give us the index of the last insect info. Oops. Okay. I greater than or equal to 0. Minus. That can actually just segments. There. Okay. That needs to return. Okay, we'll create this before then, so we have something to return. Otherwise, we'll get compiled error. Okey-dokey. So now should be able to call a transport network segment, split segment single. Passing in the base segment, current insect info at that index. Yeah, so we do need to do this, because this is also a static method. Okay, and then add that to new segments. should be all good. Should be. Oh boy. Yeah, maybe it's this. I'm guessing. Okay. All right. And finally, let's delete this. And delete that. Now we can finally where do we actually call it? It's the network actor. Yeah. So we update the network. We create network segment. Split self-intersecting segments. There we go. So that we can now ditch. Assign that to that. Cool. All right. So I'm not too sure how I'm going to visualize that, but in theory, in the outliner, if I do a single spline and have it intersect itself, we should in theory see 3 segment actors. Or it'll just crash. All right. So we'll pull this down. We take a look at that outliner. So there's this segment. Yeah. Cool. Yeah, don't ignore the actual not visualizing in the editor. It's a bit buggy when you start clicking on the sequence there. But that seems correct. What are these errors for? Raise change during range for iteration. Okay. Whatever. Just Yeah, cool. Huh. Yeah, there's actually working. So it's doing the collision on that last one. Okay, happy days. So that seems to be roughly working. There's some errors to sort out, or yeah, it doesn't like one of the iterations, but whatever, I'll deal with that. But that seems to be working. And if I take a look in the, yeah, it's properly segmenting it. Just a shame the debug visualization is kind of buggy anyway. There's not too much I can really do about that. Cool. Alright, sweet. Yeah. Oh yeah, that's actually added an extra one. Cool. Alright, well, that seems to be roughly working, so I'll leave it there for today. I'll sort out that warning gets given out for the iteration, and then I'll have a little think about how I can better visualize that it is actually fully working correctly. And we can then start doing the splitting on segments that aren't, because at the moment we're doing this on single segments that intersect in themselves. We're not currently running this on two different segments. So that'll be the next step, is running this on all the individual segments, checking if they intersect each other. But I'll cross that bridge next time. So yeah, hope that's useful, and catch you next time. Cheers.